Hey, good morning, Algebra 1, periods 1, 6, and 7. I'll bet you can't guess who this is or where this is being shot from. Well, just in case, this is Maze, room 308. All right, I've been looking at some of your mini quizzes and some of the other homework you've posted in there, and I decided this morning to make a quick video on how to find the axis of symmetry and the vertex of a parabola. Because if you're missing those two first crucial steps, the rest of it does not happen for you. So this is what I'd like to do today. I'd like to discuss how to find the axis of symmetry and the vertex in the following example. Okay, so here we go. Algebra 1, Chapter 8, finding the axis of symmetry and the vertex, given an equation in standard quadratic form, f of x, remember that can be a y also, is equal to ax squared plus bx plus c, all right? Now, it's something that I took for granted in some earlier videos, that putting it in standard form is the first step. We discussed that way back in Chapter 7. But anyway, please don't forget that. That's the crucial first step, is to put it in standard form, okay? So you need the squared, then you need the single, and then you need the constant on the end. Remember, the power, the exponent on the x, step them down from biggest down to littlest. That's standard form, all right? So here's the example I chose to use. I've got f of x is equal to x squared minus 2x minus 8. Is it in standard form? Yes, it is. Now, to identify the a, b, and the c, it is simply the coefficient in front of the squared term is a. In this case, it's a 1 because nothing there. Okay, it's implied a 1. The number in front of the x term is a negative 2, so b is equal to negative 2, and the number hanging on the end is negative 8. Okay, so I've identified my a, b, and the c, and that's something that you are required to do on one of those worksheets out there, is put it in standard form and identify the a, b, and the c. Now, the axis of symmetry. I need the axis of symmetry, okay? Because I know the vertex is on the axis of symmetry. And if nothing else, when I find the vertex, I can identify the minimum value of the parabola, or I can identify the maximum value on the parabola, depending on whether it opens up or down. Now, this formula for the axis of symmetry, x is equal to negative b over 2a, you have to know that. That's another thing. If you don't know that one, you can't even get the car out of the garage to start your road trip. So x is equal to negative b over 2a. Now in our case, a is equal to 1 and b is equal to negative 2. So to find our axis of symmetry, x is equal to the opposite of a negative 2 over 2 times a, which is 1. All right, neg, neg, pause, divide, x is equal to 1. So that is the axis of symmetry. The axis of symmetry is x is equal to 1. Okay, so here we go. I drew a quick sketch of that, okay? So I drew my little grid, and the axis of symmetry is x is equal to 1. See that dotted line right there? That's the axis of symmetry. Now I also put in the y-axis intercept, okay? Remember, every point on the y-axis has an x value of 0. Therefore, when you go back to the equation that we started with, if you put a 0 in for x, 0 squared minus 2 times 0, well, that's a 0, and 0 minus 8 is negative 8. So the f of 0, or when x is equal to 0, y is equal to negative 8. That's one of the useful things for identifying c. Now, there's some significance to that y-axis intercept. You know this parabola opens up. Therefore, the vertex had better be below that point. It's got to be below that point. So when I'm identifying this, when I solve this, when I find the vertex, it better be down there below that somewhere. Okay? All right, so how do you do that? So the vertex, the x component of the vertex is the x value of the axis of symmetry. So our x is 1. So go over here, there's my vertex, put a 1 in the x slot. You need y, you need the y value. Well, y is equal to x squared minus 2x minus 1. Insert y is equal to 1 squared minus 2 times 1. That looks like a plus sign, doesn't it? Minus 8. And if you do all that, 1 minus 2 minus 8, y is equal to negative 9. Y is equal to negative 9. We'll get rid of that. All right? So now I know the vertex. Blip. Okay? Now, is that point below my y-axis intercept because this parabola opens up? You betcha. There it is. There's my vertex. Now I can do one more point because I know it's symmetric. I can go 1 to this side. Whoops, that's a 2. Common -8. Okay? So there's 3 points. There's 3 of the 5 points I need. And then, of course, the next thing I do, I would factor this next and find my x-axis intercepts. But that's a brief discussion on how to find the axis of symmetry of a quadratic in standard form. I gotta start re-emphasizing that standard form thing. Identify your A, B, and your C. You only really need the A and B to get the axis of symmetry. And that formula, man, you gotta have that. You got to have that, okay? Plug them in, take that x value, plug it into your original equation to find the y value. You found the y component of the vertex, you found the x component of the vertex, boom, there's the vertex. Okay, hopefully that helped you out a little bit on finding the axis of symmetry in the vertex. And so keep up the great work. Keep those assignments rolling in here. I put that on here because that one graphing the quadratic worksheet, it requires you to find the vertex and the, well, axis symmetry and then the vertex right off the bat. And if you can't do that, boy, are we in trouble. So, and then also that mini quiz on 6 and 7. Most of you have turned that in. If you have yet to turn that in, please verify that your information is correct before you submit it. All right, more to follow. So happy Thursday. It's 23, I think, 23 April already. Yep, 23. So anyway, that's all I got for you. May's out.